Alright, so here's the video for rational exponents for those of you that have been absent the last couple days. Now, those of you in 7th hour, there's quite a few of you, we just practiced more rational exponents today, so the rest of the class is getting very good at these, and you are not. So I need to make this video for you guys to kind of catch up. It's a pretty simple concept, though, so really, don't fret too much. Let's just get started. Kids are in the bedroom. It should be quiet for the time being, okay? 4 to the 1/2. Now the dog starts. Obi, go. I just started. Go, go, go. This is the 4th time I've taken him outside. No, this is attention seeking. All right, so we got 4 to the 1/2. Now 4 to the 1/2 is obviously it's not an integer exponent. It's not a negative number. It's not 4 to the regular like first or second or third power. It's a half. So what does that mean? And that's what we want to investigate. So what we want to do is we want to look at, let's just say that you have this base of a. All right, and we're going to basically say that a is any number as long as a is positive. Okay. No, actually, a doesn't have to be positive. We want a number that actually will be raised to m to the n. Now, all this is saying is that a fractional exponent is doing two things at the same time. It is both raising to a power, but also taking a root. All right? Now, the raising of the power comes from the m part. Okay? So this is us raising a to the mth power, but we're taking the root of the nth. All right, and we've seen things like this already, actually, towards in the beginning of the year. So what this is saying is that we would take the nth root, whatever that may be. Usually it's a square root, just because we work with that so often. But the nth root is here, and we raise a to the m. All right? And we can simplify if we can, but typically what happens is that, we just leave it as a fraction. So to go back to the 4 to the 1/2, what we would do is we would say to ourselves, okay, well, the m is the first power, so 4 is being raised to the first power, which is just 4, so it's kind of meaningless. But what's important is that we need that 1 there to make the denominator actually exist. So we're taking the second root of 4. So I could write a 2 there, but when the 2 is missing, just remember that it is a square root. All right. So I'll write a 2 just for now, but this is what it looks like: 4 to the 1/2. That's it. 4 to the 1/2. So I can take the square root. 4, it's 2. Okay? So we work that logic through everything. That's it. Okay? We work that logic through every single component here. So if we said the square root, okay, let's go ahead and start some examples. And these examples are different than the notes that we took. So, so those of you that need some extra help, watch the video. All of them are different. All right. Let's say you got the square root of x. How can we write that as a fractional exponent? Well, x is being raised to the first power, but you're taking the square root. So if I wanted to rewrite this, it would be 1/2. And that's it, because you're raising x to the first power, but you're taking the square root. So that's what 1/2, and this is the most common. We see this all the time, especially in calculus. We see fractional exponents all the time. All right, so we have to be very solid with this if we want to kind of advance our mathematical knowledge of not only technology but also of the universe. So how about this? So we'll just put examples here. We'll make a list. What about the square root of 8x? Okay, well, let's simplify this first. I can actually take a pair of factors out of 8, namely 8 is actually 2 times 2 times 2. So I can take a pair out, all right, and have a 2 on the outside, okay? But when I take the 2 out, I'm going to have a 2 left. Well, you know, never mind. I don't have to write a parenthesis. A 2x. Now, if I want to write this as a fractional exponent, what I would do is I would write 2 right there. Square root is just a 1/2, so I would write 2x right there. Okay, so the 2x is in parentheses because that's what you're taking the square root of. All right. Now I could have looked at this a little differently. Maybe I could have just went like this. Okay, I went like that first. All right, and that's fine. And then you just look at it. Okay, well, if I distributed this, I would go 8 to the 1/2, x to the 1/2. Again, I can take out 8 to the 1/2. There are a pair of factors there, and namely it was 2. So that would have been 2 times 2 to the 1/2 times x to the 1/2. All right, so since they share the same exponent here, I can do this. All right, same way. So all roads lead to Rome, essentially, for that. Okay? All right, so let's just keep going. This will probably be a longer video. You know, feel free to well, you know what? Let's just keep going. X to the 3/4. What is that? Well, I don't know what x is. So all I can do is possibly convert this to a radical formation, just so I understand what's actually happening. What I'm doing is I'm taking the 4th root, okay, the 4th root of something that is being cubed. And that's it. I mean, there's nothing else to do. To simplify this, there's nothing. I mean, the only way I can simplify this is if I had 4 identical factors inside the radicand, and I just have 3. So there's nothing coming out. So this is fine to leave unless it tells you to convert it to radical form. Okay, so if you understand these two are identical, then that's great. So let's keep going. What if it was reversed? Now let's flip it. Okay, what if you had x to the 4/3? Now in calculus class, this is better. Like, you want to leave it like this, all right? And that's it. But if you want to understand what's actually happening, you're taking the 3rd root of something being raised to the 4th power, okay? Now this can actually be simplified. So if I wanted to take since I have 4 x's here, I've got a triple, all right? And we did this back in October. So I can take out a triple, which is an x, but I still have 1 x left over, so that would be 3rd root of just x. Okay? We've done these before. So this we've done before, but we didn't know that this is identical to this. So it's really just, it's a new way of looking at the structure. Now there's an advantage to that we're going to get to in a couple more examples. Okay? So I'm going to keep going. Actually, let me just kind of scoot over. I'm going to try to use as less paper as possible today. Let's say that we got, I don't know, keep going with the examples. 20x to the 10/7. Okay, so one of the things that you want to understand is that the 10/7 does not apply to 20. It doesn't. The 10/7 only applies to x. If I want the 10/7 to apply to the 20, I'm going to have to put parentheses around it. Then this exponent would be distributed to both. Okay? Exponents distribute over multiplication. They don't distribute over addition or subtraction. That would be like some binomial theorem type stuff. This can distribute over multiplication. So it only applies to the x. So the 20 is just there. Okay? But we're taking the 7th root of something that is being raised to the 10th power. So I've got enough. I've got enough inside my radicand here that I can take out because I need 7. So what's going to happen is I'm going to take 7 of these 10 and pull them out. And how many do I have left? Well, if I take 7 out, I've got 3 left. So I'm going to raise it to the third. So what that does is it does kind of change my fractional exponent here, where I have 20x times x to the 3 over 7. Okay? Now, that's usually fine, but just remember that if you understand the structure, this is just as well. It's not an issue. All right? If you understand that this can convert to this and this can convert to that, then there's really no, there's nothing, I don't want to say, nothing. Maybe I should pause the video and think about it, but I won't. I'm going to keep going. So this is really no big deal. Don't fret it. Next one. Okay, so here's the advantage. Here's the advantage of understanding fractional exponents. The fractional exponents kind of work like this. You really can't experience the power of fractional exponents until you get to calculus. Then you will say, thank you. Thank you, Newton. Thank you, everybody before Newton. Omar Khayyam. Thank you, Gauss, Frederick Gauss. Thank you, all these mathematicians that understood that fractional exponents are really the way to go. So we're going to raise this guy to the 3 over 2. Okay, so this is quite strange, but just take a second to think about what you would have to do. Like, what did we learn last week about an exponents? And remember, that's a 1, okay? What did we learn about this guy and these exponents on the inside of the parentheses? I'm going to pause for a second. And while you guys are thinking about it, okay, hit pause on the video. And I'm just going to go ahead and grab my guitar. And we're going to... No, I'm kidding. I'm not going to play a song. Pause. You thinking about it? What are you going to do with 3 over 2 and 64 and x to the 4th? What are you supposed to do? Like, what if that was just a 3? What would you do? Good. You thought of it. Good job. Oh, hit the mic. Sorry. Yeah, good. You multiply. All right? And that's fine. So, what you do is this. You distribute the 3 over 2 to the 64. Then you distribute the 3 over 2 to the x to the 4th. Now, the x to the 4th would be 4 over 1 because it's just 4. Okay? There's no root being taken, so you just put a 1. But you're going to multiply to 3 over 2. Okay? That's crucial to understand that you are distributing this because exponents will do that over multiplication. So, we've got 64 to the 3 over 2, which we'll worry about in a second. But the x is going to multiply the fractions. So you just have to multiply fractions with these. You don't have to think, well, if I got 4 of them, I'm taking the square root, but then I raise it to the third. No, don't worry about it. Just multiply the fraction, then think about it. At this point, we have 4 times 3, which is 12. And then we have 1 times 2, which is 2, obviously. So, this is reducible, all right? We've got 64 to the 3 over 2 and x to the 6th power. Okay, that's fantastic. So this guy's already done. This guy's reduced. Now we only have to worry about 64 to the 3 over 2. Well, here's what we need to do. This guy should always be first. Always take the root, shrink the number, then expand him. Okay, so let's take the square root of 64 first, because remember, now x to the 6 is already there. He's already part of our answer. But if I look at this, I've got 64 to the 3rd power. All right? But this is, if I raise 64 to the 3rd power, I'm going to have this huge number that I'm going to have to take the square root of. So instead, look at it like this. Take the square root of 64, then raise him to the third power. These two are identical. All right? So grab the factors outside of 64, take that square root, then raise it to the third power. It's much easier to deal with. So I'm going to have the square root of 8, I'm sorry, the square root of 64 is 8, raised to the third power. All right? And I don't know what 8 to the third power is, so I'm going to look at that real quick. 8 times 64. I could do that by hand, but I'm off the clock. So let's do 8 to the third power, 512. So 512. So to put them together now, take your 512, put him as the coefficient, and then x to the 6, and that's it. Okay, that's how this is identical to this. And this is much more friendlier. This I understand. All right, I take 512 and multiply it to x to the 6th power. This, not so much. Okay? All right, so we're already at 16 minutes for this. Let's see. I've got a couple more examples, but what I will do, though, is if you understand this, great. And then when you guys come back, I've got some a couple worksheets, skill sheets for you guys to work on. But I'm going to put a couple more examples, but I don't want this video to get too long. It gets kind of time consuming to upload it into Google Classroom. So I'm going to stop here, and then I'm going to do 2 more examples in the next video, which will be much more shorter. All right. Hope you guys did well at the track meet, because I'm assuming everybody who needs help is probably at the track meet. So hope you guys did well. And I'll see you tomorrow if you don't feel like watching the other videos, but I would. It'll just be 5 minutes for the next 2 examples. All right, bye.